Welcome to channel Edu9, and now today we are going to discuss about sandwich theorem of sequence. What is sandwich theorem? Sandwich theorem states that sandwich is something like the vegetables are between two breads. Now the statement is like that: un, vn, wn be three sequences of real numbers and there is a natural number m such that un less than vn less than wn for all n greater equal to m, while m is a natural number, and we can see that vn is a vegetable and un and wn are two breads. So vn is between them. And if limit un and wn goes to L, that is un and wn are two convergent sequences which converges to the same limit, that is they are made of same materials, that is bread, and here the vegetable, then will also converge to that particular limit L. So what is the proof? Clearly un and wn are convergent sequences converging to the same limit L. Then by the definition of convergent sequence of real numbers, it is clear that we can find out a natural number k1 for the sequence un, and we can find out another natural number k2 for the sequence wn, such that mod of un minus l less than epsilon for all n greater equal to k1 and wn minus l less than epsilon for all n greater equal to k2. And we can see that in these two cases the limit is L. So k1 and k2 both are natural numbers. Then any one between them is larger than the other. We can consider them as k3. So k3 is maximum of k1 and k2. So the maximum number must satisfy these two relations. So this relation is satisfied by k3 and this relation also is satisfied by k3. So we can state that from this L minus epsilon less than un less than L plus epsilon, and from this L minus epsilon less than wn less than L plus epsilon for all n greater equal to k3. And now we consider k as the maximum of k3 and m. Why? Because we have seen that the relation un less than vn less than wn is satisfied by n greater equal to m. So this relation must be satisfied, and this is depending upon n. So we consider the maximum values of k3 and m. So this is k, and it will satisfy the relation L minus epsilon less this, because we know that wn is always less than L plus epsilon when this is less, for all n greater equal to k, and un is also greater than L minus 1. Combining these, if we see L minus epsilon less than vn less than L plus epsilon for all n greater equal to k, which implies vn minus l less than epsilon for all n greater equal to k. This is the definition of a convergent sequence vn to a limit l. So limit n tends to infinity, vn equal to l. So this completes the proof of sandwich theorem. Our next result is, let un be a convergent sequence of real numbers converging to u, then mod of un converges to mod u. That is, a sequence un is convergent and we construct a new sequence mod of un. That is, if there is some negative terms in the given sequence un, then we make it a positive term sequence. All the terms of mod of un sequence is positive, and we have to prove that the sequence mod of un must converges to mod of u. So we are given that un is a convergent sequence, so which is converging to u. So by definition of a convergent sequence for a pre-assigned positive epsilon, we can find out a natural number k which must satisfy the relation mod of un minus l less than epsilon. That is, the difference between nth term of the sequence and the limit of the sequence must be less than epsilon, which is positive, and this result will hold for some particular natural number k, which is depending upon chosen epsilon. Okay, so clearly also we can say that from the results of inequalities that mod of mod un minus mod u less or equal to mod un minus mod u. Again, from the result 1 we can see that mod of un minus u is less than epsilon for all n greater or equal to k, which is satisfied in the result 1. So from this we can see that the sequence mod of un is convergent to the value mod of u, and this is satisfied by this relation. So from this we can conclude that mod of un is a convergent sequence converging to mod of u. This is our result.